Hi, my name is Massimo Banzi and I like to make stuff. Welcome to another Arduino tutorial video. Today we're going to be learning how to use Arduino to move things in the real world. To do that, we need to learn how to control a DC motor using Arduino. So the DC motor is a simple electromechanical device that you see here that it's normally powered by a 9-volt battery. And we're going to be building a circuit that lets Arduino turn on and off this motor, and we'll be using that to control this color wheel that we have manufactured using an old CD. So in the kit, you will find parts in order to build the wheel adapter, and you will find a paper that you can glue on top of the CD. So what are the issues that we have to take care of? Well, first of all, the DC motor here works normally at more than 5 volts, which is the standard voltage that the Arduino operates at, and requires more current than a single Arduino pin can provide. Normally, we can just hook up a regular LED to an Arduino pin because the amount of electrical current that the LED needs in order to operate is low enough that you can power it with an Arduino pin. But in the case of the DC motor requires a current which is much higher, and we risk burning the Arduino pin if we try to hook it up directly. There's also another issue that we have to be aware of, is that when you turn on and off a motor, an electrical motor, when you turn it off actually, it generates a spike of negative voltage that can actually go back into your equipment and destroy some of the parts. So in order to solve this problem, we are going to use a new component that we haven't used in the other videos, which is called the MOSFET transistor. This is essentially a switch that can be turned on and off by applying or not a voltage to a certain pin of the MOSFET transistor. So the MOSFET here has 3 pins called source, drain, and gate. The power MOSFET is essentially an electronic switch that can be turned on or off by applying a voltage on a pin called the gate. So this MOSFET transistor has 3 pins called gate, source, and drain. So if you apply a voltage to the gate pin, it connects the gate and the source together, like I was pressing a button on a switch, but this is all done electronically. So I can use this to connect the battery to the motor, and since the MOSFET is sitting in between, it basically connects and disconnects the motor from the battery, and I can control this through software that I write on the Arduino board. When you turn off an electric motor, it normally generates a spike of negative voltage that can actually destroy your equipment. So even if the MOSFET is quite strong, it's still very sensitive to these negative spikes of voltage. So we have added to the circuit this flywheel diode, it's called, that basically conducts only when the motor generates these dangerous spikes of voltage and protects the MOSFET from burning. So what the MOSFET is doing for us, it lets us control loads that are larger than we can normally do with an Arduino pin. It lets us operate at a voltage which is higher than the standard Arduino voltage. So as I said, Arduino operates at 5 volts, but with the battery here it's 9 volts. So using the MOSFET allows us to switch on and off bigger loads that operates at voltages that are higher than the Arduino standard operating voltage. It protects us because if something happens, the MOSFET blows up at worst. But using the diode, the way we hooked it up here, we can actually protect the MOSFET, and we have a fairly reliable and robust way to turn on and off but even change the speed if we want of this DC motor. So let's look at how we can build this circuit. First of all, we place the MOSFET on the breadboard, and then we connect the negative, the black wire of the motor right in the middle pin. Then, if you look at the MOSFET from the front, where you can see the markings on the front, then the pin on the left-hand side, that's the gate. So we're going to wire it up to pin number 9 on your Arduino. And then the pin on the right-hand side, that's the ground. So we're going to connect it with the jumper wire to the ground rail here on the breadboard. Then we're going to connect the ground from the battery together with the ground on the breadboard, so that the battery and the Arduino have got the ground in common. This is a condition needed so that the power supply on the Arduino and the battery have got the ground in common, so the voltages are all referring to the same ground and the circuit can operate properly. The circuit works like this. We connect the 9 volt coming from the battery directly to the motor, and then from the motor we connect the ground pin of the motor to the MOSFET, and then the MOSFET connects to the actual ground on the circuit. So when the Arduino pin turns on and off, a 5 volts voltage will be applied on the gate. When the gate receives the voltage from the Arduino pin, it will connect the motor to ground and the motor will start to spin. When we remove the voltage from the gate pin, the MOSFET will open and the circuit will break and the motor will stop running. Let's look at the sensor part of the circuit. In our case, the sensor is a button. So we wire up the circuit in the usual way. We have a button here. We have the resistor, which is a pull-down resistor. So we connect power to the button, button to resistor, resistor to ground, and the point where the button and the resistor connect is where we connect a wire to take that voltage and bring it to pin number 2 on the Arduino. So every time I press the button, the Arduino detects that condition and turns on the MOSFET. So here we have a motor, and there's a small adapter that adapts the motor shaft with this pinwheel that we manufactured using an old CD and a piece of paper that you can find in the kit. So once I created the adapter, I'm going to put a little bit of glue on it so that the CD is not going to fly away the moment I turn on the motor. So let's put a few drops of glue. Let's try. You see now that it's picking up speed and it's turning into this interesting cappuccino color. And if I release the button, the motor starts to slow down. That's pretty good. Okay, so this was our example, and now let's have a look at the code. So starting from the beginning, we have a couple of constants. Switch pin, which maps the switch to pin number 2, and motor pin that maps the motor onto pin number 9. And then we have a variable called switch state equals 0, which will contain the state of the push button, and it will be used in an if statement to determine if the motor has to be on or off. Then let's look at the setup. In the setup we have pin mode, motor pin output, so that defines that the pin that connects to the MOSFET and controls the motor is an output. And pin mode switch pin input, that basically says that the pin connecting to the push button, it's an input. Then let's now look at the loop. Inside the loop we begin by reading the state of the button by saying switch state equal digital read switch pin. So this reads the current state of the button and then places high or low inside the switch state variable. After that we have an if statement, if switch state equal high, so if the button is pressed, digital write motor pin high, so that turns on the motor. Else, digital write motor pin low. And this if statement looks at the state of the button. If the button is pressed, we turn on the pin. If the button is released, we turn off the pin. When the pin is on, the MOSFET connects and starts the motor. This is all the code that's needed to build this simple application. Now you can hack the software and add more functionality. For example, if you look online, you may be able to find some code that teaches you how to turn on and off the motor when you press, or if you press again, it turns off. So in order to operate a toggle switch, or you can learn how to change the speed of the motor. So the number of things you can do now with this project are a lot. If you remember to build it, hack it, and then share it, because Arduino is you.